Good afternoon, everybody. So I'm Germain Tesnière from IDELE, the French Livestock Institute, and I will present some work carried out in TechCare project with a huge package of activities regarding pilot and large-scale testing on farm. So this work has been done with all the pilots, so I'm not explaining only what I've done. So thanks for all the partners to providing information for this presentation. So the main objective of this work was divided in two steps. So the first pilot tries and then the large-scale studies. For the pilot try, we tried to test many promising innovation on farm with different operational environments. We tried, was a little bit difficult, but to capture variation in welfare indicators in different production systems. And we also test the robustness of the technologies on farm conditions with climatic difficulties sometimes, and also difficulties coming from the animals themselves. Then we will have a presentation of the large scale, but the idea was to pre-select the main useful and robust technology to be tested on commercial farm later. So I will explain the objective later in the afternoon. If we spoke about the pilot farm activities, we will have two main steps, two presentations, on-farm trials and then transportation trials. Regarding the overview of the pilot trials, we want to give you this because it was a huge work of many, many trials in different countries. So we had 8 experimental farms in 6 countries involved, and we had those trials during transportation also, in trailer and in boat, in 3 countries. All those trials were covering 3 sectors, so meat sheep, dairy sheep, and dairy goat. And you can see some figure about the, a sum up of the numbers of trials we had, 25 in total, regarding trials done in Norway, UK, France, Italy, Spain, and Israel for the pilot studies. We were trying to follow, let's say, a little agenda within the pilot partners. So we had like 5 main steps. It's nothing very new, but what we were trying to do. So we had this first work looking at the farm facilities and production system to find any relevant farm that we could use for the, let's say, innovative trial with the technologies. So we were scheduling some potential try according to the facilities and also the weather, the season and the weather. We were pre-selecting the technologies regarding what Cathy was just presenting this morning, what can be useful for what kind of indicators. We were writing the protocols, of course, and scheduling the trial along all the 4 years of the activities of this work package. We were also spending a lot of time setting up the technologies, the installation, doing calibration also, and then data collection by each sensors and many observation of welfare assessments. Different scores, observation by visual observation, also handling scoring. A big step that was very, very time-consuming for us was the database cleaning, of course, and data analysis with the relation of some partners who were analyzing this in Israel and other countries. And then sometimes we had difficulties in obtaining welfare issues, so we tried to repeat some trials to get more data, more welfare assessment, and unlucky animals, but more problems for them. So we tried with this organization to draw pre-conclusion for the large-scale phase and choose the tech that we could deploy on commercial farms. So I will speak about some highlights, not everything because it's too big, but some highlights per sector. So I will start with the meat sheep situation. Here you got a table, a little bit huge and many information, but you can focus on the 2 last columns that presenting the main indicators in black that we were looking at, and in red the welfare issues we wanted to address. So you can see that there was many topics about lameness, nutritional issues, parasitism, heat stress, and some of them also myositis in midship. I won't go into all the details, but you have also in the last column the technology we were testing, different colors, but you can see that similarities. We were looking at identification with low frequency or high frequency, depending. Bluetooth beacons, Claire and Cathy was mentioning before, and there will be a specific session on Bluetooth tomorrow. We were also, all the pilot studies, I forgot to say that, but all the pilot studies were also using weather station indoor sensors for the indoor facilities to monitor the heat and cold stress. So there will be also a presentation with Gerardo just after mine regarding THI and a new app. But we were also using wall-cover weight system, wake rate with EID, low frequency, and some connected water meters. So for the midship, I will try to give you a little story about how we were using the UHF RFID system as an innovative tool. We know that for now, the official system is the low-frequency RFID for the animal identification, but we are convinced that in one way, UHF can offer many other potential use case in the future. So it can be used for many potential use. The main advantages is that with the UHF, with the high frequency compared to the low frequency, you can read different tags, several tags at the same time, not with the low frequency. And you can also have a reading range very large, up to 6 or 10 meters, depending on the settings. So this example is based on the SRUC work. It was a trial during winter with 50 ewes outdoor grazing in the rangelands. And there were, this trial was also used for the nutritional issues and lameness focus. So we used the system. I won't explain it a lot because there will also have a presentation about UHF system tomorrow, but you can see in the black box, there was the UHF suitcase related and connected to the antennas, that you have both antennas next to both feeding blocks with MELAS. And each animal was wearing a UHF ear tag to be identified by the antennas. This system is collecting many, many data. Each second, the antenna is searching for new tags, so you have at least one line per one tag per 1 second, so you have millions of data if you follow them, the animals for weeks or months. I think it's more or less the main information about the technology, but during this trial, there was data collected about the welfare assessments, so there was weight, body condition score, lameness, parasites, indicators, fleas, cleanness, dental loss, respiratory issues, etc. I won't go into all the details. And of course, all the data coming from the UHF systems. In this case, it was an outdoor situation. We were facing many issues regarding battery connections. That's important to be mentioned. And there was a little bit difficult to collect every day and every hour data, but at least we had 8 hours a day data collection, except during the weekends. This is an example, so you should remember what Cathy was explaining this morning about the potential of this tool, but the story was how we could use those UHF data, raw data, as a potential indicators for the farmers, but also the technicians, to follow and track the attendance of the animals to a point of interest. Could be a block of MELAS, could be a water trough, you will see just after, but how we can use this data to follow the attendance. So the first idea was to try an indicator about the numbers of day each ID, means each animal, was detected next to the block of the MELAS. So in the graph, you can see that this is an histogram per ID, so one histogram was for each ewe, and you can see that there was many, many difference between the ewes, individual attendance, up to next to 20, and some of them never came to the MELAS. So there is a huge variability, so that's why we were thinking that could be relevant for tracking animals' behaviors, but also potential welfare issues. But because of the dataset was not a continuous dataset, we cannot follow the longitudinal attendance of each individual. So that was something that we can't do at the moment. But there was some other indicators really interesting. Just on the right of the slide, you can see that the total ID count per day. So for each day, how many ID animals were detected. And you have just next to this graph, the rainfall indication. And it was something really interesting because for us, for outdoor systems, that when there was many rainfall, those animals were not really going to the melasse for a nutritional point of view, let's say that. So next to this, we had also another issue, but was mainly a common issue for all the pilot trials. There was not so many welfare issues during the time duration. It was like 1 month for this one. So we can capture variation. We do not draw a very strong conclusion about those variations because of the few cases we have with lameness or other problem with the welfare and health. But we tried to continue the work also indoor. So this is more or less the same system. You can see at the top the UHF suitcase reader. You have an antenna in red just next to the lamb. The lamb is wearing the UHF ear tag and is drinking at the water trough. So it was done in France with IDELE. It was during summer with 60 fattening lambs indoors. And we were also looking mainly at lameness at the beginning. That was the objective, but we were also collecting other data about any welfare issues. We were collecting weight also, scores regarding fleece cleanness, fecal soiling, respiratory issues, and injuries on the legs, for example, and all the data from the UHF system. So we tried to keep going on what kind of indicator we could use for the potential alerts. At this time, we are thinking that watering is important for each lamb, so they should go to the water trough several times a day, depending the weather and the heat stress, of course, but at least they should go every day to the water trough. So first indicator for question was, are all lamb ID detect around the water trough every day? So you have those small histograms are per 1 day, so you can see that 1 day there was 1 animal missing during the trial. So that was interesting for us to follow and to check if this lamb was affected by any issues or problem during the trial. So we get with this representation a good overview of the ID, so the animals' frequentation of the area of the water trough. Also, that the system of the UHF is currently running. There is no problems with UHF, with the power supply connection or internet connection also. But with this simple indicator, you only know who is missing, but you can't say that there is a decrease or an increase of the attendance. So we are keeping looking at the data and trying another indicators that we call visits. So this visit has let's say, main filter. We only consider data and between 8 and 120 seconds. And with this filter, we apply to all individual data ID. And the question was, how does the individual attendance is going through during the trial. So you can see in this graph with the box plot of all the lambs during the trial that some of them are with colors, as Cathy explained as an example. So we try to follow 2, so the green one and the red one. And if you remember with the previous indicator, there was 1 lamb missing. That was the red one, sorry, who was suffering from arthritis. We can see a deep drop in the attendance, and one day he didn't came to the water trough area. For the green one, it's another type of evolution. He was more or less in the middle or next to the last part of the box plot, and then we can see a decrease at the end. It's also depending of the way the animals are affected by the health issues. Everything is different, so this is not sometimes affecting their way of walking as a lameness. So it's interesting to see variability between individuals. We have many, many patterns of lambs and ewes, something that we could keep going to analyze with the behavior patterns. The filter is sufficient to see clear drops or differences between attendance, and some of them are related to welfare issues, but there are still too few cases to have big conclusion about if we can see this drop, this is because of lameness or something like that. This is ongoing work. There is another thing that we have tried with the pilot activities during TechCare. It was another tool developed with the Israeli colleagues. It's a prototype that combines two things. It combined the RFID system, UHF, detection at the water trough, the same idea, with two other sensors, the flow meters to evaluate the water intake, and also an automatic weighing system with the two front legs of the animals. So this trial was done during summer with different use indoors, looking also for lameness, many other welfare issues. I won't go into all the details. And the data collected was also UHF plus weight, water intake, and also some scores of welfare assessments. Here there is two examples. I won't go into detail because tomorrow you will have a presentation of this tool called Trough AI, but you can see that they develop a dashboard to study how does the individual attendance of the water trough area evolve during the animals are inside of the barn, and also regarding the growth and the weight. So they try to identify with indicators like individual daily weight or number of visits to the water trough, the same system, difference drops or any relevant evolution, and they developed an algorithm and a dashboard for monitoring this. So they gave us two examples, for example here, that they can predict or identify pregnancy toxemia and lameness issues. So they can use it as a real-time monitoring tool of any animal vital parameters like those ones, to check also the attendance of the animals, and they can also develop some early alerts for the farmers. But there were also few animal disease problems, so they can't quantify those indicators, but there is still promising result about this. So you will have a detailed presentation of this tomorrow. So if we draw a little bit feedback of the UHF system, so we are happy because we can track several indicators about the individual attendance of the animals. We can have behaviors, patterns, really interesting for following different months during the trials. We can detect some health and welfare issues at early stage, but because of the difference we have between lambs or ewes, we cannot for now assure that every drop or evolution is related to a welfare issue. So it's still a proof of concept to be studied a little bit longer. With the second system, with the integration of several sensors with the weight, flow meters, and also the UHF system, with this combined device, it's also interesting because they are using for several years now in this in the farm. They can try to identify indicators for the farmers, observing the flock growth, for example, monitoring animal health also, and giving them alert about many things useful for the management of the farm. So you, as I said, page up and also through AI will be presented tomorrow. If I go to the dairy sheep system, there was also many trials done during the TechCare project. So you got the same overview. Partners from Italy, France, and also Spain were looking at nutritional issue, mastitis, heat stress, also sometimes cold stress in the Oviaragon region, lameness, and other welfare issues. So we had also a list of technology tested, connected milk tank scale for the flock production, individual milk makers for the individual production, all those sensors related to the heat stress for the indoor and also outdoor situation while grazing, the UHF, the low frequency system, and also, I'm forgetting something, yeah, connected water meters and portable somatic cell counts. Today, we will highlight the work carried on Italy with the Agris team. So it was a 4-month trial during spring with 500 views during lactation. It was also indoor and outdoor, depending on the day. But they were focusing on mastitis and also nutritional issues and maybe other welfare that could appear in the trial. And the objective, they were using lots of technologies to see if they can find any relevant evolution regarding this big data set regarding the welfare issues evolution. So they were collecting also scores about BCS, DAX scores, lameness, also the information about the flock level, about animals' diets, the access time to the pasture, and everything. Regarding the technology they used at the same time, it was the Laval micrometers with the DEL Pro software, the RFID low-frequency boluses inside the animals, and also the readers. So with this kind of data, they got two main, let's say, yeah, two main other, but the main ones were individual milk productions, milking order at the milking parlor. They were also using the weight crate system, the weight scale static, with the data mass system and using the RFID low frequency also to get the live weight. The milk scan and for somatic to get milk analysis of individuals and also for the at the flock level. And the milk tank scale for the group production level, and there was a station and indoor sensors in the barn. In this work, they were working with the Abinsula company to develop and create a dashboard specific to the farm. Then they can record all the data at the same place, download and combine the data to get some interesting figures and to see if they can identify drops in evolution that they could be an alert. So just after the work package 5, I can't remember, it's today, yeah, just after it's today, you will have the presentation of the Abinsula platform by Francesco. But a word about this work, because it was a huge work of a big data set that you can see in this short example that they can identify the milk yield drop for an individual ewe during the trial, and there was an alarm report sent to the farmer and the research team at the same time for this tool. So they developed an alert system with some thresholds that are still ongoing to be implemented in the platform. We are still trying to work on this. And those thresholds are used for the alarm report to the farmers about any welfare or health issues regarding an individual ewe or the group level. From this big data set, there was another work carried out with the Agris and also the Arrow organization in Israel with Gili, who was doing a statistical analysis with the data set from the milk production and the SEC level of the ewes during the trial. And they were focusing on the relationship between milking order change and SEC level of the individuals. So this first work is an ongoing work, and they are trying to publish it. I won't go into the details. Cathy was presenting the graph between the different changes, but first highlight is that changes in the voluntary entering order to the milking parlor could be or may serve as an indicator, an early warning indicator of the elevated somatic cell count of the SARDA use. So they believe that predictive model can be used and to help the farmers to optimize resources and improve animal health and welfare at the farm level. But there are also direct measures that could be done, but they are still useful, but they are limited option to do because of the scope of the measurement and also the frequency of doing it. While there was this analysis, at the same time there was another work interesting carried out by the UAB partner in Barcelona regarding the milking order of healthy and subclinical mammary infected dairy ewes in mid-lactation. So I won't explain all because there are many, many results, but you have the reference with the work conducted by Ricio and all the team of Gerardo Caja. And they were explaining, they were maybe not convinced at the beginning about the relation between the milking order and also the SEC level, but there was an hypothesis, let's say more large, that healthy ewes should come earlier to the milking parlor and the sick ones should come later on delay. So that's the big hypothesis of this milking order thematic, let's say that. But they identify a problem that in mastitis regarding small ruminants, they have low prevalence for clinical, they have high prevalence for subclinical, and there is a controversial debate, let's say that, with the SCC level and the link between this evolution of the order and the typology of the mastitis. So for them, the intramammary infection needs to be assessed by a bacterial culture, and that was the objective of the trial at the UAB station. So the work was done in the experimental farm of UAB during the mid-lactation, about 50 days, 112 ewes, and during lactation and indoor settings, and focus also, of course, on mastitis. So they use three main different technologies, let's say, summarized in this way. The milk meters, individual data regarding the production of each ewe twice a day during the milking. The IDELE laboratory facilities to get the analysis of the milk composition, and the bacterial also cultures was done for each individual when they were identifying an SCC level very high, and they'd done the bacterial analysis 1 week after. I won't go into all the details. You have all the information that are published online in the TechCare website, but some conclusion of this trial were really interesting for us. They were asking themselves if the milking order feasible as an early warning system for mastitis in dairy ewes, so more or less the same question, but different way of digging into the topic with these bacterial cultures. So, Gerardo, I tried to summarize your work in this way, but we say that in this data set, not the data set from Agris, but which data set with 100 ewes in Spain, SCC was not enough sensitivity for subclinically infected sheep udders. For them, the milking orders do not discriminate enough now, subclinical intramammary infections for the dairy ewes. It depends more on the body weight, the breed, and also milkability and parativity of individuals. They still believe that last entering ewes have worse udder health, but maybe not related to this SCC level. So other indicators should be explored for the mastitis topic. So there is still interesting work to be done for the researcher, and happy ewes will be happy with these new indicators. To finish the presentation about the goat, if I still have time, Claire, yeah. We will see different work done with the partner from Norway, with Lise. For now, we were explaining many technologies, many trials that were working more or less good, and sometimes it's not so easy, and we will have a good example in Norway of difficulties in implementing technologies outside in mountains. There were three main trials carried out in Norway related to milking order, daily milk production and weather condition. Distance work was really also interesting in Norway, and also, again, another one in another farm about milking order and milking production. Focus was done on mastitis, lameness and welfare issues related to the capacity to walk in the mountains. Yeah, that's it. Regarding technology, it was also a UHF and low-frequency test to track the milking order and also to track the walking order in the bridge. I will tell you just after. Weather station, individual milk meters also in the milking parlor, and indoor and weather station, like all the pilots for the THI study. So this is a view of the farm. That you can see that the building facilities are on the one side, and the other side, they are the grazing area. So the goats for this trial were obliged more or less to cross the bridge to go to the grazing. So it was mainly outdoor for this part, but except for the milking, and they were focusing on mastitis and lameness. So they were trying to register the milking order in a way, and also the order of the goats on their way and return to the pasture. They were also collecting welfare assessment scores, and that was more or less all the technology installed on the farm. So with a station, milk meters inside, the RFID low frequency and the RFID UHF from PageUp were installed, as you can see just here at the beginning of the bridge, to collect data about the tags and the order of the animals. And they were also using a GPS collar named Real-Time ID from the company Real-Time ID, sorry, and also Bluetooth ear tag related to those GPS collars were communicating with the GPS on the neck. Regarding those tries and those technology, Liz and her team were facing many, many challenges. So that's the moment we are explaining what didn't work at all for those tries. In those challenges, first, that welfare issue is the same topic. It's difficult to keep and to find variability when we are looking at healthy animals. We are finding few cases of lameness, so there was no data analysis possible for this with this few cases. And the second one, indoor, that goats are very curious about everything, including technologies. They were eating most everything, so they were showing the beacons and showing all those technologies and ear tags. You can see that the UHF ear tag and also the Bluetooth beacons the goats were enjoying every time. Outdoor challenges regarding also those techs that with the tries with GPS and Bluetooth beacons. The team was really happy with the technology, but it's still a promising technology because the poor quality of the data set for now. There are difficulties in data collection and data transmission between the Bluetooth and the collars, GPS collars. So the objective was to calculate the distance walk per goat, but at the end the goat were more grazing and walking as a flock, so there was no many difference between individuals. And as I explained before, with few lameness, there was no many data difference between the individual way and distance walked by the goats. So actually more research is needed, but the system is still promising tech, and they are still working with the company to improve it. So there will be something interesting to consider in the future for an early warning system. Regarding the order and the use of the low frequency and UHF into the bridge, there was big also challenges, but related to outdoor conditions about setting this kind of technology in the bridge. There was first difficulty in adjusting the reading range in this system to detect all the IDs, so they miss some reading data and missing also ID numbers during the days. And there was also climate change challenges related to the weather condition in Norway. So one day the bridge was completely broken and all the technology were in the floating in the river. So this was the situation in Norway, challenges, and also challenges the court because it changed also the way they were grazing in Norway among all those grazing areas. So if we can summarize all those work in few words, we can say that pilot trials give us a great example of rising technologies. We tested it various sectors, various environmental conditions, but still many challenges related to small ruminants. We have innovative approaches to capture variation. We have variation, but the difficulty is to relate it each time with welfare or health issues. We have too few welfare cases to draw a very final conclusion, but we are still interested in the development of the technology, and we think that this is promising trends to be explored in the next project, for example. So the study needs to be continued. We further investigate the data with the large-scale phase we are doing now, and there is still work to do to find many other indicators, maybe relevant ones, that we didn't identify for now. So with those tries, we had the possibility to pre-select, let's say, 3 main technologies for the large-scale phase, which are the weight crates associated with the low-frequency RFID, individual milk meters with low-frequency RFID, and indoor sensors and weather station. Those main 3, they're used to the large-scale farm for further validation and collecting data that we will present just after. And I think this is it, and we thank, and I think also all the partners involved in the large-scale drive with all the challenges. You have a picture of many of them there, and they're really, really happy doing this, and I will thank you again for this.
Thank you, Germain. So we might have time for one quick question before we move on to the transport trial. Any pressing issues? Otherwise, we'll keep them for the discussion at the end of the day. Okay, so we carry on then. So the next one, I think we start with Gerardo. Yeah, we'll talk about transport of kids and lamb, and then we'll move on with Cathy in 15 minutes, Gerardo, to talk about the sea transport.
Okay. Well, thank you very much. Okay. Well, this is part of my research in a group in the University Autónoma of Barcelona. You can see they are. It's a pity that my colleague Ali El Hadi is not today here, and the other. I hope they are following us by remote. But in any case, which is the reason of this research? If you remember, in our first meeting, we discovered that transport was not incorporated into the experiments, and we decided there in Scotland, in Glasgow, to do something related with the problem of the animals that we have in our experimental farm. This is the case basically because we are working with dairy animals, the milk-fed lambs and kids. It was a surprise for all of us that when looking for the information related with the European Commission regulations, well, despite having more than 20 million, or around 20 million of lambs and kids moving in Europe, there was no regulations related with them. Well, also we go deeper inside of the currently important regulation related with animal transport, the one 2005, which is currently under discussion. This is a good opportunity to introduce some changes that we also detected imprecisions and lacking related with these animals. Well, the aim of our research was, as a consequence, to monitor the transportation using the classical physiological indicators from blood, basically, temperature, etc., but also using the PLF tools, which is the aim of the project. And this is, in a short summary, we took the animals, we take samples of blood, of temperature, we measure with different devices, infrared thermometers, etc. We put in a small trailer, and we move simulating that they go to the slaughterhouse because they are a short number of animals, and normally they are in the areas, they are slaughtered in the areas, and on average we make a consultation, and in 2 hours most of them arrive to the farm or to the slaughterhouse. After that, we unload the animals. Of course, we take again the same measurements and blood sampling, and also we let them to recover to be sure that if we slaughter the animals after the stress, probably they will be not in good condition. We tested if they recover or not after approximately 22 hours more. Well, this is the frame of the regulation. When we look for which dimensions, which stocking density we need to use with kids. You can see it down. This is not included in the regulation. Well, we go to the small lamps, and I observe also, as is marked, one thing which is very confusing, which is indicated they should be under, well, they might be under 0.2 square meter per animal. Well, but what that means, you can stock them more than necessary. Well, we decided to put small lamps around 0.2 or more than 0.2. And well, according to this, using the trailer that we use in our experimental farm, and also looking in the market for cheap devices, here we have these accelerometers with the cost of a pair of them is approximately 60 euros. And also we use a data logger that we have for other experiments and this sound recorder, which is also a very cheap device. In total, we equipped our trailer with no more than 200 euros to monitor what happened during transportation. Well, this is the data of the animals. The animals, we make 3 trips. We repeat it with 75 kids. You see the weight is 9 kilos. Well, the reason is that we want, in the south of Europe, to put in the oven at home 1/2 carcass. That means you cannot put in your oven a big animal. This is the lambs and the milk-fed kids. And in lambs, they are a little bigger, 13 kilos. This is the standard weighing, and well, this is the space we calculate kilos per square meter. Well, with all this, we put and we make the same trip each time. In the kids, it was 3 trips. You see the animals. And also, well, it's a mountain, but good road, no? And the duration was approximately 2 hours. Exactly the same, in the same circuit, with the same trailer, with lamps, in 2 hours, you can see. Well, and this is the result that advanced Cathy before. It was a surprise. When we decided to compare, which was the vibration, the acceleration, in the cabin of the driver or in the place of the animals, we got dramatic differences. We were unaware of this, and it was really nice to see, especially because after 3 Gs, you cannot support driving. That means for them, it's impossible to stay, in most cases, on their legs. Well, and also the other thing that is never tested was to record sounds. Well, I'm marking here a hard rock concert because I recorded with the same device, and they were around 300 decibelium, and also a machine working or a very heavy traffic, you can see. Well, they are supporting 5 times, 3 times this strong noise. Well, related with the frequency, I didn't make the analysis, but they are approximately listening the same things that humans, but probably they are more sensitive than we are. Well, in any case, they are more noisy than expected. With this, we tested with the classical data, the performance of the farmer, which is what happened with the weight. Well, all animals during transportation lost weight, but it's normal. They are defecating, they are urinating, they are respirating, they are losing weight, but after they recover. Well, the important thing is the travel was, of course, significant, but when we analyze high density, low density, according to the regulations, there are no differences. It was a nice surprise for us. And according to this, as farmer, I will say, don't worry about, put the animals with the strict stocking density of the regulation. Well, but what happened with the hormonal data, with the physiological data? Well, the same. The cortisol was peaking, clearly. It was more peaking in the small kids than in the large lambs. That was, for them, was more stressing. And the other thing which is important is density was no affecting. At least we were not enough significant to demonstrate differences. We analyzed creatine kinase, no results according to stocking density, and lactose dehydrogenase, which is an indicator of the use of glucose, was not affected by the density, of course, was affected by the trip. And according to this, well, I will not go in details, but you can see that I only stress it in yellow what is significant. And here I clean it. This is for kids. Which is significant? The trip. The trip is really stressing. But only the temperature in the lacrimal point with infrareds or in the iris are showing tendency, as well the fatty acids in blood. That means probably they are mobilizing body fat. With lambs, the same effect. You can see very few stresses in yellow. And when we'll clean that, only urea, which is not really relevant, and body weight were affected. Well, finally, I can conclude that despite traveling these very short journeys, they are stressed because we saw clearly the impact of the travel. And the kids were more stressed than lambs. Body weights and metabolic indicators recovered after resting. That means in most cases, quality of the meat will also improve. We detected these strong shocks and loud sounds, noise during transport that need to be avoided. And both the lambs and the kids also showed cold stress. We measured temperature, and some of the kids arrived just shivering because they were, despite being with mild temperatures, it was with open windows in the trailer, and they were really not well in temperature. And finally, we recommend the use of low densities, approximately this 0.016 meters per kilogram, which is in practice 6 to 8 kids per square meter or 5 to 7, no more than this. Well, thank you very much. This is all, and as they said, they thank you for transporting in a mile, no crowded, no shacking, and no noisy room. Thank you very much.
Thank you, Gerardo. I think we'll move on with Cathy and maybe have a question after you both did your presentation.
Okay, so now we're going to turn to a different way of traveling. This is often when we think about animals traveling by sea, where I think we probably very often think about animals doing very long journeys to the Middle East. But actually around Europe, often animals will still be traveling by sea, maybe within a country or between countries in Europe, much shorter journeys, but nonetheless, there are still the same kind of issues of traveling in this different form of transport. So in Scotland, in particular, one of the issues we have is animals coming from the Northern Isles, so the Shetland Isles, right up in the very far north of Scotland, or the Orkney Islands. And these animals make these journeys not for slaughter, so we can't fix the problem, if you like, by putting an abattoir on the islands. They often come to the mainland as fattening or for breeding. So these aren't slaughter journeys that we're talking about typically. And about 140,000 sheep per annum will travel from the Shetland Islands. And we also have mostly cattle coming from the Orkney Islands, although also some sheep as well. So these are long journeys in particularly challenging parts of the world, can be quite rough, these seas. And although there's a shorter crossing from Orkney, the roads between Orkney Islands and Aberdeen, which is the main sort of distribution centre for these animals, are very small, winding roads. So they're pretty challenging roads for road transport. So often the sheep or the cattle will travel from the islands to Aberdeen by ship. And they will travel in one of these containers that you can see over here. So there's a specialized container. It's sort of like a pen that's bolted to the deck of the boat rather than traveling in a normal livestock transporter. And the seas can be interestingly variable. So they can be beautiful and flat, and they can be very rough. And it's up to the captain of the ship to decide whether the ship will sail and whether the livestock can travel on that ship. And the sea journey typically for animals will be anything between about 9 and 15 hours. So this exceeds the travel time within the European Union, but because they're in these specialized containers that provide bedding, food, and water, it's considered neutral time. It's not a rest time, but it's also not considered to be travel time. And one of the things that we looked at in this journey was whether this designation was really suitable or not, and what were the challenges that the animals experienced. So we accompanied 3 journeys of sheep from the Shetland Islands to Aberdeen. We also had a PLF that made many more journeys that we didn't go with. These were commercial journeys, so they were commercial sheep. We instrumented 36 compartments, so 12 on each of our accompanied journeys, and that was just over 1,200 sheep that were within those compartments that we observed. So they were animals that arrived. We couldn't mark those animals, but we could record. We couldn't take blood samples because they were commercial animals. But what we did was use PLF to understand better the components of the journey. So if you travel on a ship, you can travel in 3 linear planes, but also 3 rotational planes. So we used a motion sensor, which had a 6-plane accelerometer that could measure those 6 different planes of movement. Like Gerardo explained, we also recorded sound within the compartments and up on the decks. And we measured the temperature and the humidity in each of the compartments and on the deck. And we attempted to measure air quality, so that was ammonia. Although we tried, I think in the end, we tried 3 different sensors, none of which stood up to the rigors of traveling on a ship. So the cattle and sheep did better than some of the ammonia sensors that we tried. Again, we weren't able to make physiological measures on these animals. We didn't handle them at all. We would put all the instruments into the compartment, and then the animals would be loaded and then loaded into the ship. So we used behavioral observations. We used wildlife cameras as they had the best battery life and they would last throughout the journey. And we made an observation for 1 minute every 20 minutes throughout that journey that the animals made. So on average, we collected data in 46 periods throughout the journey. And we looked at standing and lying, idling time, rumination, whether they were eating or drinking, and we also looked at panting or labored breathing and vocalizing. And we also looked at, and so those are sort of continuous, and then we also looked at involuntary responses to movement of the ship, so that would be adjusting position, falling, slipping, and so on, and collisions with other animals or with the walls. So this is what these things look like. So on the top, the top right, you can see what one of these containers looks like. There's 2 decks. So sheep would travel in the middle deck or the top deck. If it was a cattle journey, they would travel just in the middle deck and nothing on top. You can see the animals, the cameras in the middle that we used. So after they were loaded, and then you can see there's a bit of bedding. So when they're at sea, if it's calm, they'll often lie down. So mostly we would see a lot of animals lying down. And then when they arrive, they would be unloaded into the lairage in Aberdeen. And we attempted to collect data at that point as well, but often a lot of the sheep would make another journey onward from the lairage, often within less than an hour of arriving. So having traveled all the way, joined the ship, traveled for up to 15 hours on the ship, they then maybe had an hour before they were then loaded onto another transporter and went on to the journey. So it was a very, very long day for these animals. So when we looked at using the PLF to assess the motion of the ship, so we've got journeys from Kirkwall, which is in Orkney, and those are mostly ones that are in blue, and the red journeys are from Lerwick, which is in Shetland. So you can see a range of different journeys that were collected by the sensors, and the darker dots, the dark red dots, are the ones where we also collected behavioral data and accompanied the animals. So you can see the range of motion for pitch and roll, which are two of the rotational movements that animals might experience. And you can see from our accompanied journeys that we had journeys that sort of spanned a range of the different conditions that the animals might experience. So we also measured sound on board the ship. So this is the average sound that the sheep were exposed to across 2 different journeys. So the, journey 1 is the darker green, and journey 3 is the paler green. And here I've just shown you the sound in decibels. The red line shows the legal limit for humans in the EU, where you need to be wearing ear protection. And you can see that quite a lot of the noise that the lambs were exposed to was greater than where we would expect to wear ear defenders. Most of the noise was around heavy traffic. And like Gerardo, I've also chosen to go with concerts for my upper limit, but you can see often it didn't quite reach that, but it was continuously in the region that was heavy traffic up to needing ear defenders. And the picture at the bottom just describes the normal environment that these lambs would have come from before they entered the ship. So the sound of waves and seabirds was probably the most common sound that they would otherwise have experienced. We could classify the journeys in terms of their roughness based on the PLF sensors for pitch and roll. So just if you ignore the blue journeys, which were cattle journeys, if you focus on the green and brown journeys, you can see that, and this graph shows the proportion of animals that stood through the journey with time along the x-axis. And so, although cattle nearly always stood up when they travelled, sheep mostly lay down, unless the journey was rough in terms of pitch and roll, in which case far more animals would then stand up in response to that motion. We didn't see any injuries that we could unambiguously relate to the ferry journey. So the animals were not falling or causing collisions with the sides of the pens. But we did have very limited data on the impact of this journey on the animals, because most of them would leave the lairage, and at that point we couldn't follow them any longer within an hour of arriving. But what we did see was when they were in the lairage, for the time that we could record data, they mostly stood up, but they didn't either eat or drink, they didn't either drink or ruminate. They weren't offered food in the lairage, but they had access to water, but they didn't drink and they didn't ruminate during that period of time. And they also didn't ruminate or hardly ruminated at all during the journey. So this is a long period of time without rumination for an animal that would probably spend up to 50% of its time normally. Its waking hours ruminating. So on those rough crossings that we could identify with PLF, the sea conditions meant that animals were more likely to stand up than lie down. If it was calm, they would tend to lie down during the journey. They didn't eat or drink for an average of 16.5 hours when they were traveling. So although they were given food within the containers, often they ate that before they'd even got onto the ship. So there wasn't any food left to eat. But they didn't ruminate, which may be an indicator of nausea while traveling. And things like falling and panting were fairly infrequent. So although we did measure THI, it was quite low for all these journeys. Remembering we were right up in the north of Scotland, it doesn't get very warm. It was warmer in the compartments than it was on the deck, but even so, not hugely different. So what the PLF sensors allowed us to do, again, like with the road journeys, it helped us to understand the experience of the animals by providing new data on the movements that animals experienced and the noise. Journeys by ship were typically very long. They were very noisy. The animals had limited access to food and water, and if they did have water, we would question whether they actually recognized the way it was delivered as water, because often there was no sign that they ever drank and the water bowls were dry. And there was rapid onward transport, so they didn't have a lot of recovery time before they made the next journey. Typically, the journeys were not particularly hot or humid. That might, again, be the geography where we're traveling. And they were actually mostly relatively calm. So even though we tend to think of this as a really challenging area if you go sailing, but it is nonetheless not as rough as we anticipated. And so often they didn't cause falls and injuries, maybe because the lambs tend to lie down if they could. It was a high sensory load for the sheep in terms of movement and noise. And on rough crossings, the animals were more likely to stand up, less likely to ruminate. And if we did see adjustments, involuntary adjustments of posture, it was on those rough crossings. Sea journeys are quite complex. There is an option, unlike on a road, the captain can sail a different route. So if they know it's going to be very rough, they may sail for longer, but more closer to they sort of follow the coast a little bit more. So the journeys can be short and rough, or longer and, well, not very short, but shorter and rough, or longer and maybe a little bit smoother. And there was none of the PLF helped us understand the experience, but they didn't clearly allow us to assess the likely welfare impact because they were so diverse with the different things that were happening in the journey. But we did believe, and I think other studies have shown this as well, that high pitch and roll, which in humans is associated with seasickness, was also where we saw most animals standing up, and that lack of rumination during that time may also be an indicator of nausea in the sheep. Thank you.
Thank you, Cathy. I think we can have maybe a minute or two of questions for Gerardo, Cathy, on the transport. Anything you want to ask? Paul.
Just a question, which is about the animal-based measures that may inform about travel sickness in these animals. I mean, if you, other than whether they can be assessed using PLF or not, which signs or symptoms should be focused?
Yeah, it's a difficult one, isn't it? I think it's one that people have thought about for some of these longer sea journeys as well. And I think it's only fairly recently, I think there was a paper a couple of years ago, that really thought about nausea in animals at all. So the animals aren't sick, but unlike other species, but the discomfort associated with that. And I think probably the lack, it's difficult to partition out whether that lack of rumination was because they had eaten all the food long ago. But I think we would have seen some rumination, whereas they almost didn't ruminate at all for the entirety of the journey, which I think probably suggests that some part of that digestive process was disrupted.
Thank you. Any questions from the Zoom? No. Okay. So thanks, Cathy and Gerardo, for that section. So we've got Germain again. His work is done with Leticia and Victor, and I think it's more detail about the large-scale studies.
Yeah, thank you, Claire. So this part of the huge work package about large-scale and pilot activities was done on commercial farms in some countries. So as you mentioned, it was done and led by Leticia with the help of Victor. So thank you for preparing the slides and all the work you've done during the project. About the objective of this second phase, it was also to continue the testing of the promising tech, but a few numbers of technology. We had to reduce the scope of the research, let's say that. And we wanted to validate the ease of the use of the technologies, but in commercial farms with less, let's say, technicians and also researchers involved to see if they are really easy to implement and to be in functioning condition during months. We also try to collect data with the technologies, but also the welfare assessment protocols Cathy was presenting this morning. The objective with this small preselection of technology was to increase the size of the data sets to refine the algorithm we were testing during the pilot phases. So we collect also at the end of the trial with the farmers, their feedback regarding their interest, the use of the technology. And this survey will be presented by Victor tomorrow morning. So the idea was to involve technician and researcher in each country. So in Greece, France, Ireland, Spain, and Romania. They have installed various sensor and monitoring device to do this in sheep, dairy, and meat, and also goat farms to collect the data. And there was focus mainly on environmental conditions, milk production, animal weight, and health and welfare dataset. So the aim was to identify potential early warning signs among those data and animals with a big number of animals in the flock size, and to refine the algorithm we are trying to implement and develop to develop some strategies with the platform that you will also see in the following presentation. So there were 8 partners involved in this part of the project, 56 farms across 5 countries, I explained, with the 3 sectors, meat sheep, dairy sheep, and goat. So you have the map of the partners and the country concerned of this in these phases. And we will give you an overview of the technology we were using. We'll also later present the installation in each country. So the first technology, it's the simplest maybe, but it was useful and already installed in some farms because it's obligation of the regulation regarding the electronic identification with low frequency. Sometimes we were testing UHF, but the main one was low frequency identification of animals. So it was at individual level. We tried to keep track the movement, the frequentation, etc. of the individuals and track behavioral changes. Regarding the milk production, we tested 2 different technology. The first is the individual milk meters, so to cap and to collect the individual productions, but not only the productions, also the order of the animal, because we were also using the readers with the EID identification at the same time. We also use in few farms, but the milk tank scale system, that was a prototype we tried to develop. We had some tries in Italy and France. It's still a prototype, so we try to develop the system with some large-scale farm, but it's still challenging, but at least we use it for an evaluation of the flock production. Some of the farmers were wondering why we wanted to do this, but when they use the milk tank scale, they often just written in a paper the milk production, and they don't have any automatic data collection about the milk flock production, so that we wanted to have it, and also see if we can check some things with the evolution of the weather conditions, for example. We also had many indoor sensors, plus the weather station in the all large-scale farms, so it was a huge part of the work. Following a pilot study done in UAB in Barcelona, we make a collective choice to select the same weather station and the same indoor sensors to be sure that we were collecting the data in the same way with the same precision and sensitivity. And the last one is the weight crate. So also something that the meat sheep sector knows, but in some farm is not used and it's not done very frequently. So the idea was to develop it to show as an example the potential of weighing animals very frequently with an electronic system, and that what can be done with the data and what can we find with the relation with welfare and health issues. So this is the pre-selection for the large-scale farms. So there were some of pre-selected welfare issues also. For the identification, we were looking at lameness, mastitis, and other illness regarding the behavioral changes and the frequentation of animals. With the milk meters, individual or flock level, depending, we were also looking at mastitis for individuals, but it's stress at the flock level. Same for the weather station. We were also looking at the quality of the bedding for one time, because we are also sensors, humidity sensors in the bedding, the air quality in the barn, if there are some hairs and system of ventilation or not, and we were looking at the respiratory issues of the individuals. Some of the farms were the animals were outside for a moment, so we are also looking at the weather condition while grazing. The same idea: temperature, humidity, THI. And for the weight crate, it was more looking at nutritional issues, body weight, growth, mastitis, parasites, and also potential issues that can happen in a normal life in the farm. So this is a sum up of the technology selected and installed in each country. So we have one line per country and one column per technology. So you can see that at least we had 68 weather stations installed in the large-scale farms, more than 1,000 indoor sensors, including the beddings sensors for the humidity, different weight crate, etc. I don't go into all the numbers, but just to give you an overview of how we can follow the condition outside and inside in all the farms. And that's it more or less, because it's summarizing the main measure we were doing at the same time in these large-scale studies. Regarding the welfare assessment, it was the same idea as the pilot we were presenting before. So there was different frequency depending of the animals, because we were studying adults or lambs depending of the sector. But the idea was to follow the same protocols presented by Cathy. So we are mainly looking at, for example, respiratory rates, other scores about cleanness, fleece cleanness also, body condition score, weight, parasite score regarding the cleanness of the fleece, but also if there was a sign of scratching or something like that. Lameness, of course, locomotion, capacity to walk, and I think that's more or less the typology of the diversity. DAX scores also, and some of the partners were looking at also fever for lamb, fattening lambs. So some observations were done by the farmers, by the technicians. They were all kept in a book, or sometimes they were also using the breeder app that you will see tomorrow. But the idea was to focus on those scores and also to try to keep on track and on the data collection and follow the same protocols. Now we will have one slide view of what has been done in each large scale. So this is for France. So there was, the idea was to pre-select 10 farms with already installed individual milk meters in the milking parlor, because it's a very huge installation and costly installation. So we were pre-selecting the farmers we were interested in the project with this kind of technology. So you can see this example in one of the French farms. They were all in the same area. It's in the Aveyron department. So it's a system using outside and inside facilities. They are inside during winter, but they are also grazing during spring and summer. Regarding the welfare assessment, we were looking, for example, in just an example about the other cleanness. So there was many data collection for each individuals at different assessment time. So you have the different score, for example, for this farm regarding the other cleanness. And to give you an overview, we try to summarize all the data we got for each, it's not only a farm, but it's all the French group farm. So we have more than 3 million of milking orders, the same numbers for the milk yield records, individual ones, and all the welfare records we've done with what Noémie has done for France. So all those data are going to the algorithm that we are trying to develop with the other partner. You will have the presentation of each one, milking order, milking production, growth of the midship tomorrow, and also the THI. If we go now to Ireland, though there are some picture of the installation team and breed has done with the farmer group. So it's midship focus, semi-intensive. There was 10 farmers involved and 2 groups, one group for the lambs and also one group for the pregnant ewes. So they install weather station, indoor sensors. You can see also a dust sensor for the air quality inside, and some picture of technician using the electronic weight crate. In the following picture, you can see the bedding sensor for the humidity that was also used in many large-scale farms. An example of the dashboard we have with this system, with the EcoWit Frogit system for the weather station. So the farmers have the possibility to consult this dashboard inside of the shed or at the office, depending, but they have all a dashboard with great indicators, and they were really, really happy to have it. So that's part of the situation of the result of the survey, but they really appreciate looking at this kind of indicators in the shed. And regarding the data from Ireland, so you have more than 12,000 of individual weight records and many indicators of the welfare also assessments. Now we go to Greece with a dairy goat system and dairy goat group of farms, 8 farms in the semi-intensive systems, and 2 were more intensive regarding the production. So you got the milking parlor of one of the Greek farm here with the analog milk meter. They were organizing the welfare assessment in 2 steps. First level of AWIN scores every 2 weeks and another level each month. And they were recording health and welfare status daily if something wrong happened in the farm with individuals. They were also using the indoor sensors with the TechCare app. So Gerardo will present it tomorrow. Oh, no, today, sorry, I'm always mixing. And regarding the data, we have many data also for this, milk yield record for goats and welfare records. Now we go to Spain. The first group was with the UAB partner regarding dairy sheep and also dairy goats in an intensive system indoor. There were 12 farms in total. So you can see some of the facilities in the pictures. They also use something that we are not very used to use. In French, for example, in the dairy sector, Gerardo and his team was using the weight crate system to monitor the weight of the lactating ewes, so something new in the project. They were developing this previously in the project. All the sensors that you see here, they were presenting as a pilot trial during the project for showing that the system is working and also the robustness of the system. Here you have a view about the record we have, milking yield, welfare indicator, milking orders also, and weighing orders for the animals, something that Gerardo was also trying to explore. If we want to check the behavior of the animals, that could be also useful to see how they go into the weighing scale, if there is something interesting to see any difference in the order. Then we go to the midship group of Spain. So it was an intensive fattening lamb system with feedlots with 7 farms involved. So there's the region of the farms are located in Spain. You have an example of the facilities. They were all using the indoor systems with the THI evolution, also the bedding quality. They were organizing in lots, so that was something very specific to the feedlots, and there was one of the challenges they have to face regarding the duration of the presence of the animal in the barn, but also the way they can use the identification for the weighing system, because they were not identified, so there was many work for Leticia and the team to do to identify each individuals and to measure the weight of the fattening lambs. They also use the THI care system app, and they were collecting a huge amount of data regarding environmental conditions inside the barn and also welfare and weight of the animals. And then I think it's the last one. We go to Romania to see how they were dealing with the dairy sheep system also in a semi-extensive, but also some really extensive farms outdoor. And you will see how Ludovic managed to install different technology in those farms, including farms with milking parlor, but also farmers were milking very outside with a simple system. So this is a great example of we can try to install or set up new technologies, but in a very, very extensive facilities for them. And it was working. So they were collecting also milk yield records, welfare, and milking orders to the milking parlors. And I think that's it. We just stop here to give you this overview, explaining how much data we are collecting, because tomorrow you will have explanation about each algorithm. But the idea was to collect more data, find any relevant welfare issues, because we are still tracking on this. And we hope that you will have a good overview of the potential of the algorithm tomorrow.